The next talk is, I believe, from Nicholas Case, and he's going to be talking about geospatial data integration middleware for exploratory analysis.
Alrighty. Hi, everybody. My name is Nicholas Case. The title of this talk is Geospatial Data Integration Middleware for Exploratory Analytics. And before we get into it, I just wanted to say this isn't just my research. I represent a team of people that work on the actual software, the wheels in the buses, like I like to call it. And then also we're part of a greater team called WYACT, which I will use this gray button for. There we go. So yeah, this work is supported by the grant called WYACT, which stands for Wyoming Anticipating Climate Transition, and supported by the NSF, the Wyoming Innovation Partnership, and EPSCoR Wyoming. So yeah, the introduction, I'm sure many of you have seen this infographic or one like it before. The world is being tracked by multiple different types of sensors and collecting many different types of data over a long period of time, whether that's through remote imagery, like Landsat, like we heard earlier today in the talk, or using human sensors, like I think I heard earlier yesterday or the day before, which I thought was a neat perspective. But we use all this data to create a model, which is a mock-up of the real world, and then ask it questions and do research. So how does this apply to what we're talking about here in the Rocky Mountains? So being from the University of Wyoming, we are concerned with the Rocky Mountain region, principally because we live there, and also it's the headwaters for many of the different areas of the US. We still have glaciers out there, and many of those watersheds point to in all directions from the state of Wyoming. So not only that is it important to the rest of the United States and the nation, but also to the state of Wyoming itself, which mostly relies on tourism, and which is second to extraction in the state of Wyoming. So that's what the WYACT grant was made to address, different societal, diminishing quality of life and societal impacts. So yes, we've heard also earlier today too about the watershed that leads to Lake Mead. That starts in Wyoming. So so yes, before we get into it too, do I get my pointer up here? Maybe not, but I got one in my hand. Well, we're mostly focusing between the top two nodes, people, organization, and communities, and data and software services. That's mostly where this talk will dominate. And then this is how we contribute between the CI contributors, CI professionals, and CI users. Our group surrounds most of those different domains, and we'll talk about that more in two different cases here. So when we say cyber GIS, we're talking about the value and challenges that domain-specific users expect or may not know about using when it comes to cyber GIS, and also the overall need for dynamic information displays, or like ways to explore the data without having to be a data scientist first. And then mainly though, our main goal is to overcome that disconnect between the cyber infrastructure, the people that know how to use the hardware and the code and all the data and the science, and then also to the people on the ground that need to use it, that don't necessarily have those same skills and don't have the time to go learn them all. So cyber infrastructure middleware, what does that mean? It's been defined many times here in this last paper talk, but when we say it, we mean we're translating that expert knowledge from scientists that are in the field doing climate research down to the person on the ground that needs to figure out how many tags they need to issue for hunting, say, or where does that windmill farm need to go without interrupting migratory animals, like such as sage grouse, for example. So when you're on the ground, without just using your eyeballs, how can we get that knowledge to that person in the field? So, but yeah, there's a definite data handling challenges, many challenges, as we've talked about today too. A lot of this data can take up many different, many petabytes of information, terabytes, which is not even possible to transfer in a reasonable amount of time to a mobile device as somebody sitting in the field, like if they have data, if they have service, which is a problem, especially out in Wyoming. And so, yeah, so we'll talk about the Y-adapt application that will that addresses those concerns. But first, we wouldn't be able to do that without talking about DEVISE, which stands for Derived Environmental Variability Indices Spatial Extractor, a mouthful. So that's what we usually just call DEVISE, and DEVISE was made in between collaboration with Wyoming Game and Fish, and also some of the professors on campus that we used to work or still directly work with the fish and wildlife. So the idea with DEVISE is to streamline the data usage down to land managers and biologists with a user-friendly web interface where you don't need to learn how to code first. Yeah, like I said, this is a precursor to Y-adapt, so hopefully my movie plays here. So this is the application in use. The idea with this is to give the user an experience of actually like exploring their data and being able to use this as a somewhat of a tool or more of a toy to be able to ask questions without having to go through the trouble of downloading the rasters and pulling the values you're interested in and putting it in a data frame and putting it on a chart and then being like, huh, what was my original question? So this way you can rapidly click on different hunt areas or counties or various spatial aggregation types and then put it on a plot or a chart and ask questions directly. So for example, this is a over on the right there. Once it comes in, you'll see it's a chart of mean snow depth from the last few years, I believe from 2018 to 2023, and you can see that at the end of the chart there, that's a very anomalous year. We had a large die-off event, and to the point where the normal amount of tags that were issued for hunting different types of animals wouldn't be sustainable because many of them died last year, but because of the sheer cold and the amount of snow. So yeah, you can see that is not normal, and actually DEVISE was used to make up that decision. Wyoming's been able to implement a point system this year, so where like you could actually turn your tags back in with a chance to maybe get better tags next year due to the accessibility of this type of data that was directly used. So I thought that was really interesting. But so yeah, what does that mean? How does this apply to infrastructure? So the cyber infrastructure that we use for DEVISE is made up of many different facets, but mostly we depend on the federated data sources, which we got to give a plug to the people involved, like USGS and various other institutions that put this out free to use. But this wouldn't have been possible without that type of data access policy. So keep your data open. We like that. So yeah, so all this federated data feeds into a virtual machine that uses R to process the data and summarize it, and then we pre-can it into our database so our device can access it rapidly and quickly without having to load multiple terabytes of data every time a user logs into the website. So yeah, we developed a divisor package, we called, an R package to, if you're more advanced, but you don't necessarily want to go and do it all yourself, you can use your R package and our APIs to download that parsed out data for you, whichever way you'd like. So this is, again, the precursor to Y-adapt, which is what I really wanted to get to here. So this is developed in support of the NSF grant, WYAC, that I keep referring to, Wyoming Anticipating Climate Transition. So here we are doing the same thing we were doing with DEVISE for land managers and state agencies, but also displaying the output of the model data. Like I said, it's many terabytes usually, and it's harder to a layperson to explore that data on their own. So Y-adapt is made up of two applications. We've got current conditions and future climate. And current conditions shows the sensors that a lot of the data is modeled off of, snow tell points, stream gauges, things like that. we are using the USGS API and RESTful endpoints to display this data, and it's just to give you an idea of like, well, what's it doing today right now? And then we link to their site, and you can view historical data as well. But future climate is where we show our model data, and that's made up of 9 different GCMs that the team has produced and downscaled for our region. So here's a look at the current conditions application. We have many different sensors that are up on the map that your users are free to click on and explore different types of data. And we also use this tool in K through 12 programs to help build that type of that data where you're able to like interpret data like for students so they know what they're looking at. So that begin at 0 can kind of help like students understand like, oh, maybe that doesn't look like as much variability as it does because it's not actually at 0. So we help this tool's just kind of more informational. This tool, this is the future climate tool where we can actually visualize our climate outputs on the map and also in the chart. And then same thing with this. This is also using K through 12 tools, schools, so we can we can export the data so that way the students are actually able to see and manipulate the data on their own, well, outside of this tool. But our focus was to make this accessible to people with as few clicks as possible. And also so that they can maybe use it to help make decisions for themselves, depending if they were some sort of business owner that relied on snow or fishing. How might less snow or less water affect your business? So what might that look like, and when should you plan for it? Is kind of what this tool is developed to address. So how are these different? One of the main things is that Devise is all pre-packaged or pre-canned data, whereas YAdapt is doing a lot of it in real time to summarize. And we're not modeling in real time, but like summarizing the data over different spatial aggregations is happening when the user requests it. This results in less duplication of data, but more computational requirements. And more, it gives us more user flexibility in defining the spatial query so it actually feels like they're doing the data science themselves, even though we kind of cut it out for them, but they're able to ask themselves preliminary questions before it's time to open the hood. So, so our implications, so what does that mean? We're bridging the gap, like I've heard most of the talks mention today, between the data that is output from climate modeling and the know-how required to understand that output and putting it into people's hands on the ground. We want to bring the science back to the normal people, which is, I believe, our scientist's job, is to put it out to the people that need it and help us understand. So yeah, with the idea with both these tools is to empower communities with the data. So this is just the beginning. We're in our infancy here, but we've got lots of work to do and challenges ahead. One of the reasons why we wanted to attend this conference is to make sure that we're on the right path, and it seems like we've got some work to do, but we're barking up the right trees, I'd say. Right now our data is using relational tabularization, but we've in the workshops we've talked to a couple people talking about these different types of data storage techniques, which we're really interested in. A lot of the atmospheric scientists on the team have plans for downscaling regional models, and which would expand our data requirements. So we're already got lots of data already. So we're gonna have to be ready for more. So yeah, one of our goals for coming here today too is to collaborate with iGuide and anyone else we could meet that would be able to help us out with this problem. And then how can we connect with other data integration efforts like Internet of Water. So in conclusion and takeaways, we all know that Geospatial's data critical role in addressing climate challenges, like the best way to communicate is with a map. And then we wanted to flesh out and publicize what we've come up with Devise and YAdapt to get any kind of feedback and things to try and things we haven't tried. But also build a dialogue and collaborate with others that are in the same space and realm so to make new tools for decision making. So with that, thank you very much for listening, and I'm happy to take any questions.